Welcome to another lesson of Math 0420 Introductory Algebra. In this video, we will be discussing stats number 1. And in this section, we will discuss how to define and calculate percents, how to define and calculate measures of central tendency, and how to calculate and define range. Let's get started with defining relative measure and ratios. Definition. A relative measure is a quotient that compares two similar quantities often a part and a total or whole. The part is divided by the total. Another definition for us. A ratio is the term used to describe the relative measure quotient. Ratios can be expressed in several forms. As words, fractions, decimals, and percents. Example 1, we want to express each of the following in all three forms: fraction, decimal, and percentage. Okay, so we'll be given one of the three and we'll want to convert to the other two. Okay, so part A, we have 3/5. So this is given to us in a fraction form. So we want to convert that to decimal and percentage. See if I can get an arrow to draw here. Maybe not. Okay, so decimal. We can either plug this into our calculator or we could do long division. This first one I'll do long division on. And it's 3 divided by 5. 5 will go into 30. Won't go into 3 at all, but it'll go into 36 times. So our decimal is 0.6. As a percentage, we can take that decimal, 0.6, and multiply by 100%, and we get 60%. Okay? Next one, 1.75. So that is given to us as a decimal. So we want to convert it to a fraction. So 1.75 is the same as 175 over 100. And we can reduce that. The common factor in the numerator and denominator is 25. So 7 times 25 and 4 times 25. Those 25s will cancel and we get 7 over 4. And as a percentage, we can write that as 175 out of 100 or 175%. Okay, one more. 80%. Let's try one more time. There we go. As a decimal, so 80% is the same as 80 divided by 100. 100 won't go into 80, so we can add a decimal and add a 0. And 100 will go into 800 8 times. And so that's 800, which gives us a remainder of 0. So our decimal is 0.8. And as a fraction, we have 80 over 100. Our common factors there are 20. So 20 times 4 and 20 times 5. The 20s will cancel, and we're left with 4/5. Okay, so that's how we would convert between fraction, decimal, and percentage. Let's try another example where we round a decimal number. Okay, example number 2. We want to round 0.785 to the nearest hundredth. So we need to go back and remember what each place value is. So this is our ones place. This is our tenths place. This is our hundredths place. And this one is our thousandths place. Okay, so when we want to round to the hundredths place, we need to look to the next digit to the right. If that digit is 5 or greater, we round this number up, and we will have just these digits. So since this is a 5, this 8 will round up to a 9. So our final answer for the rounding is 0.79. Let's do another example, a word problem. Example 3. A study was conducted of pleas made by 1,860 criminals. Among those criminals, 1,750 pled guilty, and 840 were sentenced to prison. Among the other 110 other criminals who pled not guilty, 98 were sent to prison. We want to answer the following. What percentage of the criminals pled guilty? So this is a part over a total times 100%. So what is our total number of criminals? Well, our total is 1,860, and 1,750 pled guilty. So this is 1,750 over 1,860 times 100%, and you can enter that in your calculator, and you get 94.09%. Okay? Part B. What percentage of the criminals were sent to prison? Well, again, it's a part over a total times 100%. But in this case, our total is still 1,860, but what is our part? Well, those that were sent to prison are not just the 840, but also the 98. So we need to add those together. 840 plus 98 gives us 938. Times 100%. You can enter that in your calculator and you get 50.43%. So of all of the criminals, both that pled guilty and those that pled not guilty, 50.43% were sent to prison. Okay, another part. Among those who pled guilty, what percentage were sent to prison? So again, we have part over total times 100%. And in this case, those who pled guilty, our total is 1,750. And among those, 840 are sentenced to prison. So our part is 840 over 1,750 times 100%, which gives us 48%. So almost half of those who pled guilty were sent to prison. Last one, among those who pled not guilty, what is the percentage who were sent to prison? Again, part over total times 100%. We can go back up. Again, this time we're looking those who pled not guilty. There were 110 of those. And of those, 98 were sent to prison. So 98 over 110 times 100%, which is 89.09%. So if you pled not guilty, you had almost a 9 in 10 chance of being sent to prison. Okay, let's now move on and talk about definitions and how to find measures of central tendency. Measures of central tendency. Let's start with the definition. A measure of central tendency is a central or typical value for a distribution. The most common three measures of central tendency are the arithmetic mean, the median, and the mode. Another definition. Data collected about a count or measure that is numeric is called quantitative data, which implies that there is a quantity involved. Okay. Data collected to describe categories is called qualitative data. Let's do some more definitions. Now we'll define the specific measures of central tendency. The mean or arithmetic mean or average of a quantitative data set is obtained by the sum of all measurements divided by the number of observations. In other words, we add up all of the measurements, all the data we've collected, and then we divide by the number of data points we have. The median, on the other hand, of a quantitative data set is obtained by finding the middle value that separates the upper half of the data from the lower half of the data set. So for computational purposes, if n is the number of observations, then if n is odd, the median is the n plus 1 over 2 observation. In other words, however many observations you have, add 1, divide by 2, and if the data points are put in order from least to greatest, that would be what your median was. And if n is even, then the median is the n over 2th observation plus the n over 2 plus 1th observation divided by 2. In other words, you take the average of the two middle observations. Let's try an example where we try and find the median of a data set. Example 3. We want to find the observation or observations needed to find the median of a data set containing n equals 18 observations. Well, first of all, is 18 even or odd? Well, 18 is even, so we need to find the average of the n over 2th observation and the n over 2 plus 1th observation. Well, n over 2 is 18 over 2, which is 9. And so n over 2 plus 1 is equal to 9 plus 1, which is 10. So, when ordered, let's try that again. When ordered from least to greatest, we need to average the 9th and 10th observations. And that only applies when we have an even number of observations, like 18. If we had had an odd, we would have just used the n plus 1 over 2 observation. Okay, let's do one more definition. Definition. The mode of a quantitative data set may be obtained by finding the most frequent value in the data set. And finally, the range of a quantitative data set may be obtained by subtracting the smallest value in the data set from the largest value in the data set. Let's now try some examples where we compute the mean, median, mode, and range. Example number 4. A store manager records the ages of each fourth person entering his store one day. The ages are below: 45, 62, 15, 16, 18, 9, 21, 33, 62, 28, and 37. And we want to find the mean, median, mode, and range. Okay, so to find the mean, we need to add all the numbers together. So 45 plus 62 plus 15 plus 16 plus 18 plus 9 plus 21 plus 33 plus 62 plus 28 plus 37. And our total number of observations is 11. When we add all of those numbers up, we get 346 divided by 11, which when we enter that into our calculator, we get approximately 31.45. Okay, for the median, our n is 11, so we need to put the observations in order. So our smallest is 9, then 15, then 16, 18, 21, 28, 33, 37, 45, 62, and 62. And that's the first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, and 11th observations. Since n is equal to 11, which is odd, we want the n plus 1 over 2, the observation. N plus 1 is 11 plus 1, or 12, over 2, which is 6. So we want the 6th observation. So our median is equal to 28. Okay, part C, the mode. Well, the mode is the number that occurs the most, and the only number that occurs more than once in this data set is 62. So our mode is equal to 62. And then our range is easy for us to see when we are in order. So 62 minus 9, which is equal to 53. So that's how we would compute the mean, median, mode, and range. Okay, let's do another example. Example 5. A store manager records the ages of each fourth person entering his store one day. He forgot a 52 from example 4. So the ages are below, and they're exactly the same as the previous example, except we've got a 52 added. And we want to find the median. So the first thing we need to do is to put them in order from least to greatest. So we have a 9, 15, 16, 18, 21, 28, 33, 37, 45, 52, 62, and 62. And these are the order of those, 6, 7, 8, 9, 10, 11, and 12. So now notice that we have an even number. Our n is equal to 12. So we need the n over 2th observation and the n over 2 plus 1th observation. So 12 over 2 is 6, and 12 over 2, which is 6 plus 1, is 7. So we need the 6th and the 7th observations, and we need to average those. So we want to average 28 and 33. So 28 plus 33 divided by 2 is equal to 30.5, which is our median of our set with 12 numbers. Let's now talk about weighted means. Weighted means. Start with the definition. In a weighted mean, some data points contribute more to the mean than a standard arithmetic mean. The weighted mean is computed by multiplying each data point by a factor called the weight and summing the products. Let's try example 6. The scores and their percent of the final grade for a Math 0420 student are given. What is the student's weighted mean score? So in this table, we have exams, 1, 2, 3, 4, the final, and the homework, what each of those percentages is of your final grade, and then we have some sample scores for what would go there. So this is actually a useful example because this is exactly the way the course is set up, and your final average is computed using a weighted mean that is exactly like this example. So let's go down and compute the weighted mean using these scores. So our weighted mean is equal to the score times the weight. So 93 times 0.154 plus 40 times 0.154 plus 68 times 0.154 plus 80 times 0.154 plus 72 times 0.23 plus 96 times 0.154. Okay, so when we compute these individually, you can do this one and you get 14.322. The next one is 6.16 plus 10.472 plus 12.32 plus 16.56 plus 14.784, which gives us a total, when we add those up. Pause the video if you need to make sure that you've got it. And our final answer is a 74.618. Let's do a bonus example. Example 7. A grocer has 3 baskets of peaches. One holds 60 peaches and weighs 24 pounds. A second holds 65 peaches and weighs 28 pounds. And the third holds 70 peaches and weighs 32 pounds. What is the mean weight of an individual peach? So how would we do this? How would we solve this problem? Well, what we can do is we can add the total weights and divide by the total number of peaches. So the total weight's 24 plus 28 plus 32. And we will divide by the number of peaches, 60 plus 65 plus 70. And the numerator, we have 84 total pounds and 195 total peaches. And when we divide that out, we find that a peach on average weighs 0.43 pounds. That is the conclusion of stats number 1. In this section, we have calculated and defined percents, calculated and defined measures of central tendency, and we've discussed weighted means. Please let me know if you have any questions as you work through your homework. Good luck on that, and I will see you